So in the last class we have seen about how to find out the maximum tension, that is how to calculate the maximum tension in the member of a cable segment, and we have solved one problem as well. So today we will see one more problem. It's based on a simple kind, and let us draw the figure. Suppose this is a cable, these are the support, this is the cable, and obviously from the figure we can see that this is the loading, where the loading will appear, because suppose the loading is 120 kilonewton, because the cable dips at this point. Okay, let us so see, this is the central dip of the cable. Let us suppose that the central dip of the cable is 4 meter, and the total length of the cable is 5 meter. The cable is bending in such a manner, that is the load is applied in such a point that the 5 meter 10 meter, that is the total length of the cable should be 10 meter, and 10 meter cable is broken at this point of time. So both the segment will be equal to 5 meter. Now the problem statement is calculate the maximum tension in the cable, that is due to the application of this load, how much the cable segment is tensed, that is the tension in cable segment. So that as a civil engineer we need to know the tension in the cable segment, because if the tension is much more than the prescribed limit, the cable may collapse, right? Okay. So to find out the tension, we can draw the free body diagram, right? What is the free body diagram? If this is the loading, so we can name it the support A and B. Okay. So the tension is acting in this two segment like this, and this is the loading 120 kilonewton. Let us suppose that this is the angle theta in between, right? Okay. So we have this is 5 meter, this is equal to 4 meter, and let us suppose the central span of the cable is 6 meter divided into 3 meter and 3 meter. So it is equal to 3 meter and 3 meter. So it is divided into 3 plus 3, that is 6, and the total length of the cable is 5 plus 5, that is 10 meter. Okay. So how to find out the total tension in the cable? If we apply a very basic principle, that is the summation of vertical forces equal to 0. So tension is acting at this direction, so the vertical force which will come into action is the cos component of the tension. As you can see, this is theta, so this angle is also theta, so this component is T cos theta, and this is T sin theta. Similarly, the tension in this segment, this is T cos theta and this is T sin theta. So theta will be represented here. Okay. So consider this right angle triangle. What is the value of cos theta? Cos theta means, we know as per the basic trigonometry, cos theta is base divided by the hypotenuse, right? So it is equal to base, that is the central dip of the cable is how much? It is equal to 4 meter, and the hypotenuse means the one sided length of the cable, that is equal to 5 meter. Cos theta is 4 by 5. So if we apply this equation, that is summation of vertical forces will be equal to 0. What we get? T cos theta plus T cos theta, that is this segment and this segment, will be equal to 120, right? So as per the symmetry of the figure, the tension in the two segment must be similar, so as to balance the structure and so as to maintain the stability of the structure. Okay. So it is equal to 2T cos theta will be equal to 120. 2T we know that cos theta is how much? 4 by 5 equal to 120. T will be equal to most probably you will get the value as 75 or like that. Somewhat you will get the value as 75 kilonewton. So, the tension in the two segment of the cable due to the applied load at point, let us name it as R, due to the point load at R will be equal to 75 kilonewton, and this is the most important parameter of the cable, that is to find out the tension. So, in the next class we will see much more topics, advanced topics on structure, and we can start a new topic as well. Thank you.